Look up at the night sky, what do you see? You see stars, you see planets, you see galaxies, you see the vast dark canvas of the cosmos. For all of human history, we have gazed upon this cosmic ocean and wondered. We asked, what is it all made of? We asked, how did it all begin? We even dared to ask, are we alone? These are the grand questions that drive science forward. They push us to build bigger telescopes, they push us to build smarter machines, they fuel our insatiable curiosity. But what if there's an even bigger, more fundamental question we should be asking? A question that sits underneath all the others. What if the reality you experience every single day is not the real reality? Think about your senses, your eyes see light, your ears hear sound. So what exactly is this simulation hypothesis? Let's break it down. The idea, in its simplest form, is that our entire universe and everything in it is not the primary fundamental reality. Instead, it is a simulated reality. Think of it as an incredibly detailed computer program. This idea was popularized in modern philosophy by Nick Bostrom, a thinker from the University of Oxford. He presented a compelling argument known as the simulation argument. It doesn't say that we are living in a simulation. Instead, it says that one of three possibilities is almost certainly true. First, civilizations like ours almost always go extinct before they can develop the technology to create such simulations. The logic is that if civilizations can create many simulations, then the number of simulated realities would vastly outnumber the one base reality, maybe millions for entertainment. For every single real universe that contains such a civilization, there would be countless simulated universes. So, if you are a conscious being, and you don't know if you are in the base reality or a simulated one, the odds are overwhelmingly stacked against you being in the one single base reality. A few decades ago, video games were incredibly simple. Think of Pong. It was just two white rectangles and a white square bouncing back and forth on a black screen. The physics were basic, the graphics were minimal. They were completely controlled by the players outside the game. Now fast forward to today, 2025, look at the video games we have now. We have vast open worlds that are stunningly realistic. They have their own weather systems, they have their own ecosystems. Imagine this trend continuing. What will video games look like in 50 years, or 100, or 1,000? It's not a huge leap to imagine simulated worlds indistinguishable from our own reality. The idea of a simulated reality isn't just an abstract thought experiment, we are actively building the tools that make it seem plausible. Consider the rise of virtual reality, or VR. When you put on a VR headset today, you are transported to another place. Your senses are deliberately hijacked. Think about the sheer amount of processing power that is growing exponentially around the world. We are building supercomputers that can simulate incredibly complex systems. We model the formation of galaxies, the folding of proteins, the patterns of climate change. Furthermore, look at the world of artificial intelligence. We are designing neural networks that can learn, create, and even appear to reason. These AI are becoming more and more sophisticated. They can write poetry, compose music. So this is not just a fringe idea whispered about in online forums. Some of the most brilliant minds in science and technology are honestly taking it very seriously. Elon Musk, he has famously stated the odds we are in base reality are 1 in billions. His reasoning is based on that same rapid progress of video games. Retro pixel games. Respected physicists are also exploring the possibility. People like Silas Bean, a nuclear physicist, have even proposed ways we might be able to test the hypothesis. He suggests that, if our universe is a simulation running on a finite computer, it must have a fundamental grid or resolution. This might create tiny detectable anomalies in the behavior of high-energy particles, like cosmic rays. The laws of physics might look slightly different depending on the direction a particle is traveling relative to this cosmic computer grid. Even here in my own field of astrophysics, the question comes up. I've personally said that the likelihood of the simulation hypothesis being correct may be very high. If you consider that we ourselves are on the verge of creating these worlds, and we are just one civilization on one planet in a potentially infinite cosmos, if other civilizations exist and they are older and more advanced than us, if our universe is a simulation, could there be glitches in the matrix? Are there clues hidden in the fabric of space-time that might give the game away? Some scientists think so. One of the most intriguing arguments comes from the very nature of our physical laws. Our universe seems to be governed by mathematical rules. Perhaps it's because it's running on a system that is, at its core, mathematical. The laws of physics might be the lines of code that define the simulation's parameters. For example, there is a theoretical shortest possible length, known as the Planck length. Nothing can be smaller than this. There is also a maximum possible speed, the speed of light. Then there is the strangeness of quantum mechanics. A particle doesn't seem to have a definite state until it's observed. It's as if the universe doesn't bother to render the details until someone is looking. This is eerily similar to how video games work. Could the observer effect in quantum mechanics be a sign of a similar processing shortcut being used by our cosmic simulator? Now let's pump the brakes. Before we all conclude we're living in a cosmic computer game, it's important to look at the other side of the argument. The case for a real physical universe is still very strong. First and foremost, the simulation hypothesis is, for now, unfalsifiable. A key principle of science is that a theory must be testable. It must make predictions that can be proven wrong. The simulation hypothesis is very slippery. Any lack of evidence can be explained away by saying the simulation is just too perfect to detect any flaws. This makes it more of a philosophical idea than a scientific one. Another major objection is the sheer scale of the required computation. Simulating an entire universe, down to the quantum level, would require an amount of energy and processing power that is almost literally unimaginable. You would need a computer that is larger than the universe it is simulating. Let's indulge the idea for a moment. Let's say we found definitive proof tomorrow. A message appears in the cosmic microwave background radiation that says, "You are in a simulation." What would change? How would this knowledge affect humanity? At first, there would likely be chaos. Our religions, our philosophical systems, our scientific foundations, all would be shaken to their core. The idea that our existence is not fundamental, that our struggles and triumphs are just data points in someone else's experiment, could lead to a profound sense of nihilism and despair. So here we are at the edge of what we know, peering into the abyss of what we don't. The simulation hypothesis presents us with a radical new perspective on the cosmos and our place within it. It's an idea that is both exhilarating and terrifying. It takes the familiar world around us, the chair you're sitting on, the air you're breathing, the thoughts in your head, and suggests it could all be an elaborate illusion, a phantom reality generated by a machine of unimaginable power. It forces us to ask the most fundamental question of all: what is real? We do not have the answer. We may never have the answer. We are like inhabitants of a locked room, trying to figure out if there is a world outside. We have always seen ourselves as explorers of that outer space, venturing forth to discover what lies beyond our world. But the simulation hypothesis suggests that the greatest frontier may not be out there, but in here. The final frontier may not be space, but the very nature of reality itself. The quest to understand the universe might ultimately be a quest to understand the system that is running it. Or a distant galaxy, but the realization that the whole cosmos is a stage and we are but players within it.